about today's lesson, which is Pangea and the idea of the continents drifting. Um, so hopefully to get to this video, you went into your Canvas, you went down to Science. From there, you either clicked Modules or scrolled down to Module 1. And you went to the latest published assignment, which is called Pangea Slideshow and Questions. You'll see the directions say listen to the entire slideshow by clicking here, and this is where you should have clicked to get to this video. Once you're done with this video, you're going to click here to make a copy for yourself of the questions that go along with this video. At the end, after you've answered the questions, you're going to submit them to this assignment. So, what we're going to be doing right now is we're going to be going over a short slideshow about Pangea. Now you might be thinking, oh my gosh, how does this connect to what we learned last week with the idea of the crust, the mantle, the outer core, the inner core, and all of that? Well, if you remember, the lithosphere, which is in the bottom part of the crust, holds our tectonic plates. The asthenosphere is in the top part of the mantle, and that's what's responsible for moving some of these continental plates because of convection currents. So we're going to look at this theory, and remember, a theory isn't 100% adopted, but it's widely accepted because scientists have shown research and ideas for why they believe it's true as to how the continents have drifted apart. So at the end of this slideshow, or this video, the goal is that you'll be able to tell me what Pangea is, what the idea of the continental drift is, and what evidence we have to support the continental drift. Remember, evidence is something that you have to prove something. Think of a crime. If someone believes a crime happened, you need evidence to back it up. So if you look over here at this GIF, we've got Pangea and how it's moved. So 160 million years ago, they believe that all of our continents were connected. Now, this moves a little fast, so I can't really stop it to show you, but you can see North America, South America. Looks like South America was once connected to Africa. You've got Australia. You've got Asia, Europe. So it's kind of showing that they were all once connected. And this is what one particular scientist believed. So, again, the continental drift is the idea that the continents have moved very slowly, again, centimeters every year. We always compare it to basically the speed of how fast your fingernails grow. The scientist that really firmly believed this was Alfred Wegener, and he believed this in 1912. So 110 years ago, he had this idea that, whoa, I think all of the continents at one point were connected. Now, if you look, he believes that in the beginning, there was this huge supercontinent connecting all of the continents. This was about 225 million years ago in the Permian era. About 200 million years ago, in the Triassic period, they started to split. You can see that this area disconnected from this area. Water came in, the land was moving apart. In the Jurassic period, he believed that the boundaries of our continents kind of started to split. The Cretaceous period, 65 million years ago, shows our continents moving even more. And then in the present day is kind of showing where we're at now. North America, South America, Antarctica, Australia, Africa, Asia. So Pangea is the earliest continent during the Permian period when Mr. Alfred Wegener really believed that all of the land on Earth fit together. Now, this idea is controversial. Many people didn't believe him, but there was evidence, and Mr. Wagner really believed that if he shared this evidence with people, that they would start to think, oh, yeah, that does sound right. That is true. So we're going to look at 4 pieces of evidence that Mr. Wagner presented to others to try to prove that his theory of um, the supercontinent of Pangea was truly how the land of was on Earth. So if you look here, there's number 1. This is our first piece of evidence. The first thing he said was, hey, guys, look, the geographic fit of all of the land kind of fits together. So if you look at South America and this part of Africa, well, what is now Africa, look like they kind of fit together like a puzzle. It's kind of ironic, and that's something that Mr. Wagner said often to his fellow scientists. Look, I think this could be true because look how they fit together. The second piece of evidence was fossils. We already talked a little bit about fossils, actually not a little bit, a lot. And the evidence with fossils is that they were found on the coasts of continents that are now a million miles apart. So if you look at South America, they found fossil remains of the Cinnonathus, which is a reptile that was about 3 meters long, pretty big, in both South America and Africa. So if these continents fit together, they found that these reptiles formed like a line right here. They were inhabited in these areas. In the Triassic area, they had the Lastrosaurus, which is this friendly looking guy, and he was in Africa, India, and parts of Antarctica, which again is odd when you think about the continents fitting together. Odd that this mammal would only be here. The fossil remains of freshwater reptile called Mesosaurus was found in southern South Africa as well as southern Africa. And then the Glossopteris was found in all of the southern continents to show that they were potentially, probably, once joined. I did some research on the Glossopteris, which is the fossils right here. It's a seed fern, and it's found on almost every continent. But what's crazy was that I read that the seeds are so large that they couldn't have been transported by boats, cars, anything like that. So it's strange to think how it was on all those continents. So that's our second piece of evidence. Our first one was that they all fit together. Our next one was the fossil evidence. And moving on to our third piece of evidence, we're going to talk about some rock types and mountain ranges. So it says here, our first point, groups of rocks from the Precambrian era are found on the coast of each continent that Wagner believes were once connected. So again, Wagner believes that North America kind of tied together to Europe, to Greenland, to Africa, and now parts of the same rocks are found right here where they were once connected. He also remembered that some mountain ranges, or found that some mountain ranges look as if they were once connected to the Appalachian Mountains. So that's kind of what this picture is describing. It's showing the Appalachian Mountains in the eastern United States, and it's showing that in parts of Scotland and Europe that they are once connected. This picture here is just showing you the Appalachian Mountains now in the eastern United States. Our last piece of evidence is ancient climate evidence. Now, if you remember, climate means what the weather's like over time. So we know that over time, South Dakota can be assumed to be hot in the summer and cold in the winter. That's our climate, how it is. So climate evidence over time is what Mr. Wagner looked at. So it says Wagner was once a meteorologist, a scientist who studied weather and climate. Wagner found ancient rocks made by glaciers in places that are now too warm to have glaciers. So in Spitsbergen Island, if you look here, these are glaciers. So this could have been once upon a time in Spitsbergen. It's not. I just found a picture of glaciers. But this is a picture of Spitsbergen Island where the rocks are clearly broken apart, and that would be from something, or that would be by glaciers that aren't there anymore. So 4 pieces of evidence. The first one is that the continents fit together. The second are some of the fossils that they found. The third are rock types and mountain ranges that were interestingly connected. And the fourth is climate evidence. So this is Mr. Wagner here. And it says most scientists didn't believe Wagner's theory because he had such a hard time explaining how the continents could move. So they're like, yeah, cool. We see your fossil evidence and your climate evidence. Cool. But how can you explain that the continents are moving? So Wagner died in 1930, about 90 years ago. And that's when other scientists started to think about, maybe he was onto something. Maybe he did know what he was talking about. So we're going to get more into what scientists did and what they started to consider to believe that maybe Wagner knew what he was talking about. But before we do, we're going to just stop and kind of think about his theories, what he believed. So important things to remember. After he died, scientists started to consider his theory. And then we're going to talk more about how we went from Pangea to right now. So we'll talk about that this week and into next week. But right now, what I need you to do is I need you to go back into the assignment called Introduction to Pangea and answer 5 questions. So, when you go back to here, it's called Pangea Slideshow and Questions. When you go here, you've watched the entire video. You're going to click here to open it and make a copy for yourself of the questions. This is what the questions look like. Now, it might look like I've typed the answers for you, but I haven't. Really, what I did here was I started, I wrote the sentence starters in for you so you can kind of get the hang of how I expect your questions to be answered. So we do expect complete sentences. It says, what is the idea that the continents moved very slowly known as? The idea that the continents move very slowly is known as. Number 2 says, what scientist hypothesized Pangea? So predicted by using research and theories to come up with Pangea. The scientist that hypothesized Pangea was named, so you'll have to type that scientist's name. Wagner believed that the Earth moved blank per year over millions of years. So, in the complete sentence, Wagner believed that the Earth moved blank per year over millions of years. So I want to know, how far did it move? What is the name of the fossilized seed fern? The name of the fossilized seed fern is, you're going to type it here. And then what are the 4 pieces of evidence that support Wagner's theory? So you're going to type the first one, the second one, the third one, and the fourth one. And again, all of these answers are coming from this slideshow that we just looked at. Once you've completely filled this out, you're going to share and export a copy to this assignment and make sure that you share and export and turn it in. Please let me know if you have questions. This assignment is worth 5 points. It is due tonight at due tonight at 11:59. So please, again, let me know if you have any questions, and from there, you can get started. Thanks.